So we have a couple Coulomb's law questions to answer. So the first is page 6, number 5. And what we're going to do is first begin by reading the problem. So we know our distance, we know the force, and we know one of the charges. We need to find the other charge. So what I would recommend you doing is writing Coulomb's law. The force between two charges is equal to the constant times charge 1 charge 2 over the distance between them squared. In this case, we're looking for the second charge, so I'm going to isolate this equation for charge 2. So my force times the distance between them squared equal to k, q1, q2. I'm going to divide both sides by k and divide both sides by q1 to get q2 is equal to the force, distance between them squared, all over the constant times charge 1. Let's go ahead and plug this in. So the force between them was equal to 45 newtons. The distance between them was 0.1 squared. The constant is 9 times 5 times 10 to the negative 6. So one thing you have to be careful of when you plug this in is that you have to use parentheses on both sides of the bottom, or do divide by 9 times 10 to the 9th and then divide by 5 times 10 to the negative 6. And when you type that into your calculator, you actually, your calculator puts it in notation of 1 times 10 to the negative 5th, which is equal to 10 times 10 to the negative 6th, which is the 10 microcoulombs, which is the answer. So again, when you type it in, it's very important that you either use parentheses or you actually type 45 times 0.1 squared divided by 9 times 10 to the 9th divided by 5 times 10 to the negative 6th. I prefer using divide because there's less mistakes involving than there would be had you use parentheses in what I have observed with kids in the past. The second homework question that came up was on number 4 on page 9, letter B. So let's take a look at that. Let's begin by just labeling all the givens. So I'm going to go ahead and do that now. Okay, so I went ahead and labeled my distances and all the charges that were given. So 72 centimeters to the left is 0.72 meters, 72 centimeters to the right is 0.72 meters, and of course the sum of those is 1.44 meters. So in this particular problem, we're finding the net force on charge C. So before we do anything, I think we can see that charge C is going to be pulled to the left by charge B because they're opposites. And A and C are actually going to repel, so that will be a rightward force on C. So we know the direction before we've actually done any math at all. So let's go ahead and try this. So we have two forces. So the force, and I'm going to change it to say C and A, so we know which two charges we're dealing with. So it's 9 times 10 to the 9th. Charge C is the 83 times 10 to the negative 6th. Charge A is 67 times 10 to the negative 6th. Distance between them is 1.44 quantity squared. Go ahead and plug that into your calculator. And when you do that, you get 24.13 newtons, and C and A both negative, so that's going to be right. And then we want to figure out the force that B exerts on C. So I have 9 times 10 to the 9, 83 times 10 to the negative 6, 45. all over 0.72 squared. So we have to plug this in. And the force here is going to be 64.84. And that was between B and C. They are opposites, so this is going to be left. Now this problem was about net force, so we know the net force is the sum of all forces. So the net force on particle C is equal to a positive 24.13. That's our rightward force. We typically make left negative, so minus 64.84. And when we do that, we get negative 40.7, which I've rounded here to be 41 newtons left. So there it is. There's your net force on C. Hope that was helpful.